Hello my scholars, you are welcome to my school channel and my name is Frank. In this lesson video we are going to be tackling JAMB CBT chemistry past question for the year 2008. Relax, do not go anywhere and we'll be right back. Welcome back to my school channel. In this video, we are going to be tackling question 26 to 49. So let's begin with question 26. The entropy change in the system above is dash. So this is a reaction of ammonia and hydrochloride gas, okay, to give us ammonium chloride. Okay, so they are asking us the entropy change in the system above is dash. So we should know that entropy simply means the degree of disorderliness of a system. Okay, and if we are moving from solid to gas, entropy is increasing. So in that case, we can say entropy is positive, right? But when we are moving from gas to solid, we say entropy is reducing. Okay, so in that case, we can say entropy is negative. So if you look at the reaction on the screen, you'll find out that two gaseous substances reacted, okay, to produce a solid substance. So this indicates that we're actually moving from gaseous state to solid state. So in that case, entropy will be negative, okay? So that makes option C the correct option, negative. Or you can as well perform some calculation here. Number of mole of ammonia here is 1. Number of mole of hydrochloride gas here is also 1. So add it together, that will give us 2, right? While on the product side, we only have 1 mole of ammonium chloride. Okay, so to get our entropy change, you just say the number of mole of the product minus the number of mole of the reactant. So that will give us 1 minus 2. Okay, and 1 minus 2 will give us minus 1. So that makes option C the correct answer. Question 27. Which of the following reaction is endothermic? Okay, we know that for an endothermic reaction, heat is usually absorbed from the surrounding in order for the reaction to take place. Okay, so option A, we have carbon. Okay, so option A here is carbon reacting with oxygen, okay, to give us carbon dioxide. And this is a typical example of exothermic reaction. Okay, because this is like, say you are burning carbon in air, okay, to get your carbon dioxide. So it's an endothermic reaction. Okay, while option B, this is calcium oxide being dissolved in water to give us calcium hydroxide. Okay, this is also an example of exothermic reaction. Okay, because in this reaction, heat is given off. Okay, while option D, okay, let's leave option C first. Option D is a neutralization reaction, and the neutralization reaction is an exothermic reaction. So that leaves us with option C, which is calcium reacting with water. Okay, like say dissolving calcium in water to give us carbon monoxide and hydrogen gas. Okay, which is the same thing as water gas. Okay, so this reaction is endothermic. For this reaction to occur, okay, there must be an absorption of heat from the surrounding for this reaction to occur. So that makes option C the correct answer. Question 28. A catalyst speeds up the rate of chemical reaction by A, taking part in the reaction, B, increases the activation energy of the reaction, C, lowers the activation energy of the reaction, D, increases the heat content, okay, increases the heat content. Okay, so the answer to this question is option C, lowering the activation energy of the reaction. Okay, so we know that a catalyst is a substance that speeds up the rate of a chemical reaction. So what the catalyst do to speed up the rate of chemical reaction is that it lowers the activation energy. Okay, so what catalyst does in essence is that it makes the atoms to break up, okay, and form chemical bonds, okay, in order to produce new substances and new combination. Okay, so that makes option C the correct answer to this question, lowering the activation energy of the reaction. Okay, so what it does is that it actually creates a new path, okay, a new route for the reaction to occur. So that makes option C the correct answer to this question. Question 29. The rate of a reaction usually decreases with a decrease in the concentration of the reactant because A, kinetic energy decrease, B, temperature increase, C, speed increases, D, reactant collision decreases. Okay, so we know that one of the factors that affect the rate of a chemical reaction is the concentration of the reactant. Okay, so when the concentration of the reactant is high, the rate of chemical reaction is going to be high because more molecules will acquire effective collision. Okay, so as a result, the rate of reaction will be high. Okay, but in this question, we're actually decreasing the concentration of the reactant. So that means we're also decreasing the number of molecules that will, okay, acquire effective collision. So this will in turn reduce the rate of the reaction. Okay, so that makes option D the correct answer to this question. Reactant collision decreases. Question 30. The substance that is used in the steel industry for the removal of carbon, sulfur, and phosphorus impurities from pig iron is dash. So we have oxygen, B, we have chlorine, C, nitrogen, and D, hydrogen. Okay, so when we say pig iron, we're actually referring to an iron with high amount of impurity, or in essence, we are saying impure iron. Okay, so the impurities that are present are carbon, sulfur, and phosphorus. So how do we remove them? Okay, so we simply remove them by reacting the pig iron with oxygen. Okay, so oxygen will combine with these impurities to form an oxide, which can be easily removed. Okay, so for carbon and sulfur, they will be removed as gaseous oxide, right? While for phosphorus impurities, they will be removed as slopped, okay, in the molten iron. So that makes option A the correct answer to this question. Question 31. Which of the following compounds of triisonitrate 5 will decompose to give dinitrogen 1 oxide and water when heated? So A, we have sodium triisonitrate, B, we have zinc triisonitrate, then C, we have copper 2 triisonitrate, and D, we have ammonium triisonitrate, okay, for short, or you can say triisonitrate 5. Okay, so when sodium triisonitrate is heated, you are going to be having sodium nitrite and oxygen. Okay, the product will be sodium nitrite and oxygen. Sodium nitrite is NaNO2. Okay, so it's called nitrite, not nitrate. Okay, then option B, we have zinc nitrate. So when zinc nitrate is heated, you are going to be having zinc oxide, then nitrogen 4 oxide, and oxygen. Okay, while for copper 2 nitrate, you're also going to be having copper 2 oxide. Okay, you'll be having copper 2 oxide, then nitrogen 4 oxide, and oxygen. Okay, when this compound is heated. Then option D, when ammonium triisonitrate, okay, is heated, you are going to be having dinitrogen 1 oxide and water. Okay, so that makes option D the correct answer to this question. Question 32. When a solution of ammonium triisocarbonate 4 is added to a solution of an unknown salt, a white precipitate which is soluble in dilute hydrochloric acid but insoluble in ethanoic acid is formed. This indicates the presence of dash. Okay, so this question is about the test for ion, okay, qualitative analysis. So option A, we have calcium ion. Option B, we have sodium ion. Option C, we have zinc ion. And option D, we have calcium ion. Okay, so this question really is actually a description of the test for calcium ion. Okay, when ammonium triisocarbonate 4 salt is added to a solution of an unknown salt and a white precipitate is formed, and that white precipitate is soluble in dilute hydrochloric acid but insoluble in ethanoic acid. Okay, that whole reaction, okay, shows or indicates the presence of calcium oxide. Okay, so that makes option A the correct answer to this question. Question 33. Lead is used for making bullets and lead shots because of its dash. Okay, so for a bullet, you are trying to create something that can penetrate into other substances. Okay, so option A, resistance to corrosion. I think you don't need corrosion there. Whether it's going to get rust or not, I think you don't need that. Then option B, low melting point. Option C, we have high density. And option D, we have flexibility. So the answer to this question is option C, high density. I think the essence is just to make sure that the lead has a certain amount of weight. Okay, so that when it is shot from the barrel of a gun, okay, at a high speed, it can be able to penetrate into into what it is targeted at. Okay, so that's the reason why option C is the correct answer to this question, high density. Question 34. Which of the following gives a precipitate when treated with sodium hydroxide solution? A, we have aluminium chloride. B, we have ammonium chloride. C, we have sodium triisocarbonate 4. And D, we have sodium ethanoate. Okay, so the answer to this question is option A. Okay, aluminium chloride. So when aluminium chloride is treated with sodium hydroxide, okay, white gelatinous precipitate of aluminium hydroxide is formed. Okay, so that makes option A the correct answer to this question. Question 35. The most common ores of iron include A, hematite, malachite, and limonite. B, we have chalcocite, calamine, and bornite. C, we have magnetite, hematite, and limonite. While D, we have magnetite, chalcocite, and bornite. Okay, so just take note that the answer to this question is option C. Okay, but chalcocite is a copper ore, or is an ore of copper. So just take note of that. Okay, so the answer to this question is magnetite. Okay, magnetite is actually tri-iron tetraoxide, which is Fe3O4. Okay, that is magnetite. While hematite is iron 3 oxide, Fe2O3. Okay, and limonite. So limonite is just like the dehydrated form of hematite. Okay, because it's actually Fe2O3 then dot 3H2O. Okay, so the correct answer to this question is option C. Okay, but of these three most common ores of iron, okay, you should know that for the extraction of iron, they make use of hematite, okay, which is iron 3 oxide. So just take note of that. But option C is the answer to this question. Question 36. The type of isomerism shown by cis and trans isomers is A, optical isomerism, B, positional isomerism, C, functional isomerism, and D, geometrical isomerism. Okay, so the answer to this question is option D, geometrical isomerism. Okay, geometrical isomerism is also known as trans and cis isomerism, and it is a form of stereoisomerism. Okay, so this form of stereoisomerism occurs when atoms are restricted, okay, from moving or from rotating around the board. Okay, and a good example of a compound that exhibits this form of geometric isomerism is your but2N. Okay, while optical isomerism has to do with something like mirror, okay, like the compound has to mirror itself, while positional isomerism has to do with the position of the functional group in that compound. Okay, while it has to do with different functional groups present in compounds. Okay, so but the answer to this question is option D, geometrical isomerism. Question 37. If the silver mirror test is positive, it indicates the presence of an A, alkyne, B, alkanol, C, alkanone, and D, alkanal. Okay, so the answer to this question is between option C and option D. Okay, so the silver mirror test is also known as Tolen reagent, and the Tolen reagent is used to distinguish between alkanone and alkanal. Okay, so if the silver mirror test is positive, it simply indicates the presence of an alkanal. Okay, so an alkanal is a reducing agent, while the Tolen reagent is an oxidizing agent. So in Tolen reagent, the alkanal will reduce the silver ion to metallic silver, which then forms silver mirror on the wall of the glass test tube container. Okay, so that makes option D the correct answer to this question. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and this will take you to my school website. There you have to download my school mobile app for your Android devices and my school software for your laptops and computer. Please go ahead and start practicing. Moving on to question 38. If glucose is heated with concentrated tetrasulfate 6 acid, it will be dehydrated to dash. So option A, we have carbon. Option B, we have carbon 4 oxide. Option C, we have ethene. And option D, we have ethanol. Okay, so the answer to this question is option A, carbon. Okay, so when glucose is heated with concentrated tetrasulfate 6 acid, the glucose is actually dehydrated, okay, and a black residual carbon is deposited. Okay, so that makes option A the correct answer to this question. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 39. The IUPAC nomenclature for the structure above is, so let's move over to the board to name this compound. So this is the compound that is given to us or that we are asked to name. So first thing first is identify the functional group. Okay, so the functional group present here is alkane. Okay, then the next is identify the longest continuous carbon chain. So let's count. Let's start from here. So 1, 2, 3, 4, 5, 6. That's it. So now in that case, we are going to be having hexene. Okay. Then the next is let's identify the substituents. So we have chlorine attached to carbon number 2, another chlorine attached to carbon number 3, another chlorine. So we have methyl alkyl group, 2 alkyl group attached to carbon number 4. Okay. So if we want to name this, of course, chlorine you call chloro. Okay. While CH3 you call methyl. Okay, of course, if I should start my counting from here, okay, we are going to be having, our double bond is going to occur between carbon number 4 and carbon number 5. Okay, so in that case, we're having 4 and 5. But if we start from here, we are having 2 and 3. So in that case, we take the smaller one. Okay, and between the smaller one, we also take the lesser number. So in this case, we say this double bond is attached to carbon number 2. So take note of that. Okay, then if you look at this, you must especially put this into consideration. Okay, so chloro start with letter C and methyl start with letter M. So in our naming, the chloro will come first before our methyl. Okay, so we actually indicate this or show this in our naming alphabetically. So let's name this. So we are starting with chloro. So chloro occurs, is attached to carbon number 2 and carbon number 3. So in that case, we are going to go 2, 3. Okay, but there are 2, so we'll go dichloro. Then the next will indicate the position of methyl. So methyl is attached to carbon number 4. So in that case, it's going to be 4, 4, right? Then dimethyl has. So we can go 2 in. Okay, so this compound is 2, 3 dichloro. 4,4 dimethyl has 2. So let's move over to the screen to check if our answer is there. Okay, so from our naming, option C agrees with what we did on the board. Okay, 2, 3 dichloro, 4,4 dimethyl has 2N. Okay, so the answer to this question is option C. Question 40. A hydrocarbon S with a molar mass of 26 consists of 92.3% carbon. What is its molecular formula? So let's move over to the board to solve this question. Okay, so one thing we must take note of is that hydrocarbon consists of 2 elements, which is hydrogen and carbon. Okay, so if the percentage of carbon is 92.3%, then the percentage of hydrogen in the hydrocarbon will be 100 minus 92.3%. Okay, so that if you add the two percentages together, your answer should be equal to 100. Okay, so our percentage of hydrogen will now be 100 minus 92.3%. And that will be equals to 7.7%, right? So by empirical formula, we write our H. Okay, write our C first, then we write our H. Okay, so the next thing is to divide by the molar mass. So this will be 92.3 divided by, we are to divide by the relative molecular mass, okay, of each of the compound. So the relative molecular mass of carbon is 12, so we divide it by 12. And the relative molecular mass of hydrogen is 1, so we divide it by 1. So if we divide this, approximately we'll be having 7.7, and here we'll be having 7.7, okay? Then we divide by the smallest mole. So if you check very well, everything is the same. This is 7.7, and here is 7.7, so we divide through by 7.7. So that will give us 1, 1. So in that case, we can say that the empirical formula EF of the compound or of the hydrocarbon, okay, of S is equals to CH. Okay, but in this question, our concern is about molecular mass. okay, of the compound. So, but we know that molecular mass is empirical formula times N is equals to molar or molecular mass. Okay, so in that case, and that is equals to 26. So let's just put it. So yeah, let's open this up. So our carbon is 12, the relative molecular mass of carbon is 12, then plus that of hydrogen is 1. Okay, and our N is equals to 26. Okay, so if we sum this together, that will give us 13, and multiply by N, that will give us 13, and is equals to 26. So we divide both sides by the coefficient of N, which is 26 divided by 13, and that will be equals to 2. Okay, so since our CH N, and we know that our N is equals to 2, so we just multiply. So we have one carbon atom here and one hydrogen atom here, so we're multiplying it by 2. So in that case, we'll be having C2H2. Okay, so this means that the molecular formula of the hydrocarbon is C2H2. So let's move over to the screen to pick the correct option. Okay, so the correct answer or the correct option to this question is option A, C2H2. Question 41. A red precipitate of copper 1 carbide is formed when ammonium solution of copper 1 chloride is introduced into dash. Okay, so this question is about distinguishing between an alkene and an alkyne. Okay, so alkene, they have double bond, while alkyne, they have triple bond. Okay, so alkyne will only react with ammonium solution of copper 1 chloride. Okay, but alkene will not. Okay, so if you look at all the options provided here, option A, we have alkene with double bond, while option B, we have alkyne with triple bond. So it's only option B that will only react with ammonium solution of copper 1 chloride to form a red precipitate of copper 1 carbide. Okay, so that makes option B the correct answer to this question. Question 42. Reduction of nitroalkanes, nitrites, and amide is a route for the preparation of dash. A, amines, B, alkenes, C, polymers, and D, detergent. Okay, so the answer to this question is option A. Okay, because amines are usually prepared, okay, by the reduction of nitroalkanes and nitrites and amide. Okay, so the answer to this question is option A. Question 43. Reduction of alkanones with lithium aluminium tetrahydride produces A, primary alkanones, B, secondary alkanones, C, tertiary alkanones, D, polyhydric alkanone. So the answer to this question is B, secondary alkanones. Okay, the reason is because when secondary alkanones are oxidized, okay, using strong oxidizing agent, an alkanone will be produced. Okay, so if alkanone is reduced using a strong reducing agent like lithium aluminium tetrahydride, then the corresponding alkanone will be produced. So in this case, a secondary alkanone will be produced. So that makes option B the answer to this question. Question 44. The product obtained when a mixture of benzene vapor and hydrogen are passed over nickel catalyst at 180 degrees Celsius is A, cyclohexane, B, cyclopentane, C, N-hexane, or you can say normal hexane, then D, we have N-pentane. Okay, so let's move over to the board to just show this. Okay, so let's quickly draw the structure of benzene, and I'm going to draw the old structure. So benzene is C6H6. Okay, so in that case, we'll be having this. Okay, so double bond here, and double bond here. Okay, so we have just one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen. Okay, so when benzene vapor is heated with hydrogen, okay, when benzene vapor is heated with hydrogen in the presence of nickel catalyst, what will happen is that more hydrogen will be added to each of the carbon atom, okay, and that will eliminate this double bond. So in that case, we'll be having this, one hydrogen is added here, and another hydrogen is added here, 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 and these bonds will break off, another hydrogen is added here. So at the end of the day, you are going to be having cyclohexane. Okay, so that makes option A the correct answer to this question. So let's move over to the board, which is option A, cyclohexane. Question 45. Polyvinyl chloride is used in the production of that. So polyvinyl chloride is the same thing. Another name for polyvinyl chloride is polychloroethene. Okay, and it is an odorless solid plastic, and it is used in the production of pipes. So polyvinyl chloride is actually produced from vinyl chloride, which is chloroethene, okay, by polymerization, okay, at a temperature of about 55 degrees Celsius under pressure in the presence of hydrogen peroxide as a catalyst. Okay, so the answer to this question is option C. Polyvinyl chloride is actually used in the production of pipes. Do you have any questions to ask? Please feel free to ask your question by clicking on the link in the description below. And this will take you to my school website. There you can ask all your questions and solution will be provided to you within a short period of time. Moving on to question 46. Detergents are manufactured with straight hydrocarbon chains so as to make them dash. So A is soluble, B biodegradable, C cheaper, and D foamy. Okay, so the answer to this question is biodegradable. Okay, so the choice of using straight hydrocarbon chains to manufacture detergent is so that their biodegradability can be enhanced, so that when they are washed into the environment, they will be less harmful. Okay, the reason for using straight hydrocarbon chain is because they are prone to bacterial attack, unlike branch hydrocarbon chains, okay, that are less susceptible to bacterial attack. So that makes option B the correct option to this question. Do you have better explanation or step to any of these questions? Kindly go to the comment section below and indicate the question number and the solution you would love to share. Question 47. Use the diagram to answer this question. The gas that can be used to demonstrate the experiment is that. So the diagram above is actually a diagram of fountain experiment. Okay, so the essence of fountain experiment is just to determine, okay, the solubility of gases in water. Okay, so those gases that are very soluble in water are normally used to perform the fountain experiment. Okay, and a good example is ammonia. Ammonia can be used to perform the fountain experiment. Okay, so from the option listed, we have hydrogen chloride. Option B, we have hydrogen sulfide. Option C, we have nitrogen 2 oxide. And option D, we have dinitrogen 1 oxide. Okay, so the answer to this question is option A, hydrogen chloride. And the reason for that is hydrogen chloride is very soluble in water, so it can be used to perform this experiment. Question 48. Use the diagram to answer this question. The color of the fountain water is A, blue, B, orange, C, red, and D, yellow. Okay, so the answer to this question is actually C. Okay, the reason being that this question is related to the previous question. And the answer to the previous question was hydrogen chloride gas. Okay, and we know that when hydrogen chloride gas, which is very soluble in water or highly soluble in water, dissolves in water, an acid will be formed. Now, if you look at this diagram very well, you see water with blue litmus. So it's actually water with blue litmus solution. Okay, so what we have here is an acid. So when an acid comes in contact with blue litmus solution, definitely is going to turn it to red, indicating the presence of acid. Okay, so that is the reason why the color of the fountain water will be red. So that makes option C the correct answer to this question. Question 49. So we are given this compound and we are asked that what is the product that will be obtained when this compound is dehydrated. Okay, so we have the following options. Option A, we have this. Option B, this. Option C, we have this. And option D, we have this. Okay, so, but you must not forget that during the dehydration of ethanol, okay, ethene is actually produced. So here is a compound, 1, 2, 3. This is a tertiary alcohol. So when this tertiary alcohol is dehydrated, what it means that you're actually removing molecules of water. Okay, so you are going to be removing this OH, and you are going to be removing 1 H from here. So if you remove 1 H from here, a double bond will be created here. So if you go through all our options, you find out that option C corresponds to what I've just explained. Okay, so that makes option C the correct answer to this question. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.